So in this lesson, we're going to talk about Venn diagrams and contingency tables. So a Venn diagram is a diagram in which the circular areas represent groups of items sharing common properties. And it was developed by a gentleman named John Venn. Most often we see 2 and 3 circle Venn diagrams, and there are such things as 4, 5, and 6, although those get quite complicated. So just a couple examples here on the first page of these notes, just to give you an idea of of Venn diagrams. We can have something that are independent events. So this area on the outside is everything that does not belong within the circle. So Democrats and Republicans, you can't be both. In other words, you can't be registered as both. In the state of Arizona, you can also register as an independent or a libertarian. So those would be the things that would be in the space down here. When there is nothing that's in common, this is actually called mutually exclusive. We can also have where things overlap. So we have Nobel Peace Prize winners and Pulitzer winners. In this overlap right here, they've won both things. The Nobel winners, this part that's in blue is just those that won just the Nobel Peace Prize. The Pulitzer is just these people in kind of the pinkish area that only won this prize. And then all the rest of the folks that have not won either one of either the Nobel Prize or the Pulitzer Prize. Here's another, this time there's 3 circle Venn diagrams. You can read through each one of these, what each section means. Whenever filling out a Venn diagram, you always want to work from the very inside out. So work from the innermost region outward. And we'll go through some examples as to the reason behind this. And here's just another 3 circle Venn diagram to kind of show you. Here's the one up here in the right is in context, where this one down on the left is just in general, kind of giving you another visual of what's going on. So let's look at this first example here. And before we get into this example, I really want to focus on what is each one of these regions telling us, or how many members are in each one of these regions. So first off, there's a statement down here that this person teaches 95 7th graders. And so then we have the first marking period. So I'm going to go ahead and label this as first. And I want to find out how many students are in this first marking period. So all I'm looking for is everything in this purple region. So this purple circle. So that's 4, 15, and 8. And that is a total of 27 students failed the first marking period. For the second marking period, we have 15 and 5 are all in this kind of bluish region. So there's 20 students that failed this second marking period. And then for the midterm, which is this one on the bottom, we have something in all of the different regions. So 1, 2, 3, 4 regions right here, 4 partitions. And we end up with a total of 33 students that failed the midterm. Okay, now this area right here, these are people that failed the first and the second marking period. So there's 15 here. The number that failed the second marking period and the midterm is 20. And the number of students that failed the first marking period and the midterm, again, this is the commonality of those two things, there's 23 here. Okay, so it's nice to know what each one of those regions is representing, and then we can partition even smaller in terms of the only. So now let's look at what this first question is asking. How many students failed both the first and second marking periods? So the first and second is this entire region right here. So really it's 0 plus 15. So we have 15 students. How many students failed both the first and second marking periods, but not the midterm? So now this time we are just talking about this region right in here because we're excluding the midterm. So this is just a 0. How many students did not fail anything? Well, we need to find out. So we had a total of 95 students. So we have 95 students total minus however many failed. So now when we figure out how many failed, we're not adding any of these numbers out here. We're adding each individual region together. And so we have 4 plus, I'm not going to add the zeros here. So then 8 plus 15 plus 5 plus 5. So we end up with that did not fail. That's everybody on the outside. And so that's going to be 58 students. And then how many students just failed the midterm? So that's, and it's only the midterm. So that's just this number out here. That's that region there. So we have 5 students. So now let's look at a 2-circle Venn diagram example. And so there are 150 freshman students interviewed regarding their registration for college classes. We have 85 that are registered for math and 70 that are registered for English and 50 registered for both. So it's telling us we need a 2-circle Venn diagram. So I'm going to do my best to draw 2 circles here. And I'm going to label one as math. And I'm going to say that there's 85 students, and English, which there's 70 students. It's always nice to make sure we label these so that we know what we're talking about in terms of our how many students or how many things, how many items are supposed to be in the circle, in the entire circle. Now we have 50 of them that are registered. Remember I mentioned that we need to work from the inside out. So the innermost is this math and English. So I'm going to start here. Okay, so that's the first thing. Now I know that 85 students are supposed to be in this circle, this math circle. And so 85 minus the 50, that means I only have 35 students remaining out here because 35 plus the 50 has to give me the 85. And then for English, I have 70 total students that are supposed to be in this circle. And so I've already accounted for 50 of them. That means I must have 20 here. So then I want to find out how many didn't register for anything. So we have 35 plus 50 plus 20 is going to leave us with, what is it? 70, no, is that 75? We end up with 45 students out here. Let's see, 5, so there's 70, so there's 105 in here, and 105 minus our 150 gives us our 45. All right, so now that we filled in our Venn diagram, we can go ahead and try and answer our questions. So how many students sign up for math only? That's our 35. How many students sign up for English only? There's 20 that are just on the outside there. How many sign up for math or English but not both? So math is really 85. English is the 70, but it says but not both. So I really just want the 35 plus the 20 to give me a total of 55 students signed up for math or English, but not both. How many sign up for neither math nor English? Well, that's our 45. And then just going to throw in this probability question. Keeping in mind probability is the chance of something happening. And we'll get into more detail about probability in the next lesson. But for the time being, just using kind of your prior knowledge, what's the probability a student sign up for math or English. Well, math or English is everything in here. So 35 plus 50 plus 20 over the total, because it's chance of something happening, chance of that out of the total of 150 students. And so we're going to end up with 105 over 150.